Hi, Assalamualaikum warahmatullahi wabarakatuh. So for today, me and my teams will present about Unit 1 matrices. So what is order of matrix? Order of matrix gives the dimension of the matrix and it informs the number of rows and columns present in the matrix. The order of matrix is general, represented as A, M times N, where M is the number of the rows and N is the number of the column in the given matrix. Also, it is important for us to know the order of matrix because the multiplication answer of the order of matrix M times N gives the number of the elements of the matrix. So for the example that we can see, for the matrix A, A11 that is read as A11, which is the element is number 2, which is the first row and the first column. Then A12 is read as A12, which is the element of the number 4, for the first row and the second column. A13 is the element of number 5. A21 is the element of number 7. A22 is the element of number 8. And A23 is the element of number 9. Next, we are going to the next slide, which is the type of matrices. In this slide, we have 4 types of matrices, which is transpose matrices, square matrices, and last but not least, row and column matrices. As for the transpose matrices, the transpose of a matrix is obtained by changing its rows into column and its columns into rows. For a matrix of order n times n, the order of transpose of the given matrix is n times n. Here the given matrix has 2 rows and 3 columns, and the transpose of this matrix has 3 rows and 2 columns. We are going to the next type of matrix, which is a square matrix. The square matrix, as the name suggests, has an equal number of rows and columns. Hence, the order of a square matrix is of the form of n times n. Here we have an equal number of 3 rows and 3 columns, and also an equal number of 2 rows and 2 columns of matrix in this example. Next, the third and fourth type of matrix is column matrix and row matrix. A column matrix has 1 column and numerous rows. Hence, the order of the column matrix is n times 1. For the row matrix, a row matrix has 1 row and numerous columns. Hence, the order of the row matrix is of the form of 1 times n. The addition of matrices is an operation on matrices where corresponding elements of 2 or more matrices are added. Matrices can be added only if they have the same dimension or order. Okay, so in this example, we will learn how to add 2 matrices, which is the matrix A and matrix B. To add these matrices, we add their corresponding elements. This means we add the elements in the first row and the first column of matrix A to the element in the first row and first column of matrix B, and so on for all of the elements. So, let's perform the addition step by step. Okay, so for the elements in the first row and first column, which is 2 plus 1, will be equal by 6. For the element in the first row and the second column, which is negative 3 plus 9, will equal to 6. For the element in the second row and first column, 4 plus negative 3 is equal to 1. And last but not least, for the element in the second row and the second column, 5 plus minus 5 will equal to 0. The subtraction of matrices or matrix subtraction can only be possible if the number of rows and columns of both the matrices are the same. While subtracting 2 matrices, we subtract the elements in each row and column from the corresponding elements in the row and column of the other matrix. In this example, we will learn how to subtract 2 matrices, which is matrix A and B. To subtract these matrices, we subtract their corresponding elements. This means we subtract the elements in the first row and first column of matrix A to the element in the first row and first column of matrix B, and so on for all of the elements. So, let's perform the subtraction step by step. For the first element in the first row and first column, 12 minus 6, we will get 6. For the element in the first row and second column, we will get negative 3 minus 1 is equal to negative 4. For the element in the second row and first column, which is 2 minus 11, will be equal to negative 9. And last but not least, for the element in the second row and second column, 15 minus negative 8, we will get 23.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azam bin Abdul Halim. So today I would like to talk about scalar multiplication, multiplication of matrices and matrix inversion method. So I will go to scalar multiplication first. So scalar multiplication is an operation in linear algebra where a vector of matrix is multiplied by a scalar, which is a single real number. So the result is a new vector or matrix of the same dimension, where each element is the product of the scalar and the corresponding element of the original vector or matrix. So this is the formula of scalar multiplication. So as you can see here, the A is A11, A12, A21 and A22. Let's say A multiplied by C. So the product will be CA11 and CA12, CA21 and CA22. So we go to the next part, which is multiplication of matrices. So matrix multiplication of matrices is an operation where two matrices are multiplied to produce a third matrix. For matrix multiplication to be defined, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So as you can see here, this is the formula for multiply of matrices 2 by 2 and 2 by 2. So A, B, which is the first row, the first row must multiply by the first column and the second column, which is A times W, B times Y, and A times S, and B times Z. And you will get the answer for the first row. And do the same thing for the second row, and you will get the answer for the second row. So we go to the last part, which is matrix inversion method. So matrix inversion method is the process of finding a matrix called the inverse matrix that when multiplied by the original matrix yields the identity matrix. So the inverse of a matrix A is denoted as A inverse. So before you want to solve a question of matrix inversion, you must know how to get the answer of the determinant. So this is the formula. To get the answer of the determinant, which is A is equal to A, B, C, and D, and you can use the cross-section method, which is A times D minus with B, C. And we go to the next, which is matrix inversion 2 by 2. If A is equal to A, B, C, D, denoted as A inverse, so the equation will be 1 per determinant, 1 per the answer of the determinant, and D, negative B, negative C, and A. This problem, how to solve this problem, you just refer to A, which is A and D change their position, and B and C change their symbol, which is positive to negative and negative to positive.
Hi, I'm Yasmin. Today I will explain the process of finding the inverse of a 2 times 2 matrix using the matrix inversion method. The inverse of a matrix is an important concept in linear algebra with application in solving system of equation, computer graphics, and many other fields. A 2 times 2 matrix is a square matrix with 2 rows and 2 columns. For example, let's consider the matrix A look like this. To find the inverse, we first need to calculate the determinant of A. The formula for determinant of A 2 times 2 matrix is determinant A equal AD minus BC. Next, we apply the inverse formula. Now, let's simplify the matrix by multiplying each element by multiplying both sides of the matrix equation with the inverse. Now, I will explain 3 times 3 matrix. 3 times 3 matrix is a square matrix with 3 rows and 3 columns. An example of such a matrix like this. The determinant of a 3 times 3 matrix can be calculated using the following formula. This determinant is a scalar value that helps determine whether the matrix has an inverse. If the determinant is 0, the matrix is singular and doesn't have an inverse. Step 2. Find the matrix of minus. For each element of the matrix, calculate the determinant of the 2 times 2 matrix that remain after removing the row and columns of that element. This process gives us the matrix of minus. Next step, change the sign of each minus according to the checkboard pattern of plus and minus sign like this. I will talk about camel rules method. This method that provides a straightforward way to find the solution of a system of linear equation using determinant. It is named after the Swiss mathematician Gabriel Kermer, who introduced it in 18th century. Let's consider a system of linear equation in the form like this. Common rules tell us the solution for each variable can be found using determinants. A determinant is a special number that can be calculated from a square matrix. The rules state like these pictures. For 3 times 3 matrix, we use this formula. For each variable, we will form a new matrix by replacing a new column of A with the constant from the right side of the equation. Calculate this new matrix will look like this. For example, first matrix we only choose 6, -2, 2 and -3. And then the second one we choose 5, -2, 5 and -3. And the third matrix we choose 5, 6, 5 and 2. And then you calculate and expand. And then you get the answers. Thank you.